I did a keynote at DevOps and I was talking about how we will look more into specifications, less about code.
Never trust a monkey to write Shakespeare. Now, the problem is that we decided we're not going to review the tests. The beauty of namely Cucumber, but generally parsable spec, is that we don't need a monkey.
DevOps changes over the last 10, 20 years or so. We've seen platform teams, we've seen this amazing DevOps engineer role been created.
I think it's definitely not early to have like AI engineering teams just because they're like among us. Sometimes they present themselves as Java LLMs, which you shouldn't trust, but AI engineering is something that should probably exist.
We're talking a lot about spec-driven development here at DevOps.
So Backlog itself doesn't create specifications. Backlog is a tool that AI agents use. Hey, I want to build this feature. Use Backlog.md CLI to keep track of the tasks and to split it into multiple subtasks. But Backlog itself should be as minimal as possible.
We in the Java and Spring communities in particular are in a uniquely amazing position right now because most people are going to use AI as an integration with their existing business logic and applications and services. That's all written in Spring. And so this is a really natural place to start your AI journey, I think.
Hey folks, Simon Maple here, and welcome to another episode of the AI Native Dev. And today is a little bit of a special episode because we're actually going back and featuring some of the most insightful pieces from previous episodes, including Baruch, Liran, Alex, and Josh. Now, why did we pick these specific speakers? Well, they're actually also going to be in person in New York with us next week in New York. And I say next week, depending on when you're listening to this, it is the 18th and 19th of November in New York City, in Brooklyn. And we have a wonderful AI Native Dev conference for you. This is going to be covering a whole bunch of different topics, but really thinking about how we use agents best and develop from a spec-minded way going forward into the future. So if you're interested in that, check out ainativedev.io/devcon, and a little bit of a sneak preview here. If you use the code SimonM50, you can get 50% off your ticket. That's Simon M50, and that brings the ticket price down to $90. If you're local to New York, please come and visit us. It's going to be a good fun 2 days, one day packed with wonderful workshops, and the second day slammed with a whole bunch of conference sessions, as well as, of course, that wonderful conference track, hallway track, where we can chat with like-minded folks about some of the things that we're up to and make wonderful networks and connections. So what are we going to hear about on today's podcast? Well, we're going to kick off with Baruch. And Baruch and I actually sat down at a conference called AI Focus back in Stockholm in February this year. And the amount of similarities we had in the way of thinking about how AI is going to revolutionize and change the way we develop software was pretty amazing. And we swapped some fairly candid stories around missing bugs, how that review process can let you down, particularly in a world where AI is generating more code than ever, and how to really make your AI strategies absolutely bulletproof and really allow developers to make sure they don't overlook the possible challenges and problems that really matter in this new world of AI development. So over to you, Baruch.
You said, just before, we want something to automate the test, we want something to create tests because we don't want to look at code, right? How true is that though, right? Because I did a keynote at DevOps a few weeks ago, and I was talking about how the world is moving into this new space where developers will continue to be creators. Yep. We'll do things in a different way. And one of those ways is we will look more into specifications, less about code.
Exactly.
A developer came up to me though at the end.
Okay.
And my last slide was, because it was DevOps UK,
right.
it was keep calm and carry on, because we as developers need to change.
Evolve.
He was super worried though. He was like, how can you put that slide up when it means we're not looking at code? He loves coding. He absolutely his safe space was clearly in an IDE, looking through code. His mind was extremely technical, loves the challenges, loves the depth. So how do those people deal with that?
So I think when I say like we don't want to look at code, we mostly don't want to look at code which is not ours. Like we're humans.
I agree.
We're selfish. We're self-centric. We most of the time listen to someone, and when we listen, what we really do is come up with a clever reply to what they're about to say without even listening.
Yeah.
We know all those flaws. Like
Yeah.
humans are flawed. And very self-centric, and this is true about code as well.
Yeah.
And the example that I gave you earlier, I obviously in love with my code,
Yeah. Yeah.
but I'm much less inclined to look at your code
Yeah.
review because, well, okay, that's just some other code.
Yeah.
Right.
Or my code that's 1 month old.
Oh,
which
yeah,
which
because-
might as well
which
be
is
someone else's code. Yeah,
Absolutely. Right. So and this is the problem with AI generated code. It's someone else's code.
Yeah.
Right. So you might look at it, and especially now when it's a novelty, you look at it out of curiosity to see what LLM does.
Yeah.
And you're like, oh my God, this is brilliant, or this is crap. But you look at it because you're curious.
Yeah.
Like in 6 months, when more and more code will be generated by AI, you will just okay,
Yeah.
it's someone else's code.
Yeah. Yeah.
Right. So first of all, you don't want to look at this code.
Uh-huh.
And obviously, the non-technical people definitely don't want to look at this code.
They want to look at intent. So they want to look at this test does this, and I can read that.
Exactly.
Yeah.
Exactly. Right. And generally, the idea that the tests are technical and written in code, I think, and that's just an assumption, is one of the reasons why DDD really didn't take over the world.
Mhm.
Because in the end of the day,
TDD, did you say?
yeah,
TDD,
like
yeah,
test-driven
yeah,
development
yeah.
didn't take over the world.
Mhm.
Because in the end of the day, if developers are the only ones
Yeah.
who can write the tests and read the tests,
Yeah.
the real question becomes, at least for me, in my experience, is why am I doing it this way?
Yeah.
I have a problem. I'm biased for action.
Yeah.
I know the solution I see algorithms running, code written in my eyes. I want to go and write code. I want to write tests.
Mm.
I don't mind write tests afterwards to
Mhm.
check that my code does what it's supposed to do.
Yep.
But starting with code doesn't make sense if developers are the only one involved in the picture.
Yeah.
And I guess I'm not the only one who thought about this problem. And this is how one of the reasons why behavioral driven development came to be 20 years ago.
Yeah.
Like the BDD thing.
Yeah.
The way BDD works is like, hey, what if the tests weren't defined in code, but were defined in spec?
Mhm.
And what BDD refers to spec is some kind of a pseudo natural language. It's called Gherkin,
Mhm.
and it's basically a set of rules that goes like, given context,
Mhm.
when something happened, then expect those results.
Yep.
Right. So basically, this is the steps. And the beauty of Gherkin spec is that it's human readable.
Mhm.
Right.
Mhm.
And the idea was that it's also human writable.
Yep.
Right. So the product managers, the business people, maybe even the customer
Mhm.
can participate
Mhm.
in writing those specs.
And it's interesting because when Agile came in, very often when we started writing use cases and things like
Exactly.
that and starting with use cases, it was a similar, okay, the language is slightly
Exactly.
different, but it was actually kind of a similar
Correct.
thing. As a whoever, I want to do
exactly.
this. With,
Exactly. Right. And then the beauty of the idea of Gherkin spec was that you take an algorithm and compile those specs into tests.
Mhm.
Now look at us moving one step forward toward building the integrity that we spoke about.
Mhm.
Because now suddenly we can have something that technical people and not technical people together
Yeah.
can sit and write.
Yeah.
And then, if you remember the rest of the chain that we started to build, the spec is compiled to the test.
Yeah.
We can trust the test. That's exactly what the spec was.
Yeah.
The code implements the test.
Yeah.
So we can trust the code.
Yeah.
Because it has to. We have to. Because if it passes the test, it does exactly what the test wants. And the tests are the result of compilation of something that we agreed our application should do.
So the areas that you care about, you should have as many of those tests as you can. The areas that you don't care about, you just allow the LLM to infer whatever code it wants, and whatever it decides,
Yep.
that's the right way. That's a way of doing it. That's an
Now,
okay way of
if
doing
it's wrong, it means that you miss some test that
Yeah.
will enforce the way that you want it. And it means that it makes some spec. It
Yeah.
misses some spec. It misses one of those use cases of given when then that
Yeah.
you just need to go ahead and
So
write.
it's an uncaptured intent, essentially.
Exactly.
Yeah.
Now, BDD also didn't really take over the
No.
world. It's even, you see it even less than TDD actually.
mhm.
And but again, my speculation why is that writing those structured, the structured intent, the spec was still a little bit too much for the non-technical people.
Mhm.
Right? Yes, of course it's readable,
Mhm.
but writing it, it's kind of annoying. Those are, when you look at when you speak with business people or product managers, they are kind of free souls. They
Yeah.
want to create.
Yeah.
They want to write Shakespeare. They don't want to
Yeah,
write
yeah.
this rigid like structure.
Yeah.
You read PDDs, it's like poetry.
Yeah. Yeah.
Right?
Yeah.
So again, those specs didn't really catch up because product managers like, that's too rigid. And then if they don't do it, developers definitely not going to do
Yeah.
it.
Yeah. Yeah.
Right? Because for some reasons.
I also think with the one of the issues with BDD is there was no hard connection between the BDD intents, the spec
Yeah.
part, and anything else.
Yeah.
It was left up to someone to then implement that. And as change happened in the business and things like that,
no one
it got
updated
stale.
it.
It gets
Of
stale
course.
in the same way a PRD would.
Yes.
And then all of a
Yes.
sudden, no one goes back to the PRD because it's
Yes.
out of date.
Yeah.
The code is the source of truth.
But now, if we automate all the way from the spec to the end product, the spec is very important,
Mhm.
but no one wants to write this Gherkin stupid thing.
Yeah. Yeah.
Suddenly, AI can help.
Yeah.
Because we don't need to,
Mhm.
right? Once we have like a specification document,
Yeah.
right? Whatever we call it, software definition document, whatever there are a bunch of, we can ask AI to formulate those specs,
Mhm.
those when given when then from it. Now we know that it will hallucinate,
Mhm.
and we know that the spec won't be exactly as what we wanted it to do.
Mhm.
For mainly two reasons. The first is I mentioned it hallucinates,
Mhm.
but the second is that it's very hard for humans to express intent into words.
Yeah.
Because of context that we have in our heads
Mhm.
that obviously LLM lacks.
Mhm.
So there is this chasm between the prompt and the intent, between what we ask it to do
Yep.
and what we really wanted it to do.
Yes.
So for those two reasons, the spec won't be perfect.
Mhm.
But coming back to the biggest benefit of the spec, because it is readable, we can actually review it.
Yes.
It's different from tests that we theoretically also could declare a source of truth and review it instead of specs. But as we spoke, we don't want to read anyone else's code,
Mhm.
and especially the non-technical people that they even cannot.
Yeah.
Spec is different
Yeah.
because it's readable
Mhm.
in your language. There are hundreds of languages translations
Mhm.
of Gherkin spec. You
Mhm.
can read it in Urdu if you feel like.
Mm.
And this is suddenly something that everybody around the table can sync on
Yeah.
and say, okay, now we can read the spec. It's not painful in English. And we can verify that what's in the spec, it's actually what we wanted to be generated from on prompt.
Yeah.
Now, if it's not, we go back and forth, we iterate until it is, or we just fix the spec. It's almost plain language.
And presumably you could almost like use LLM as a judge as well, to some extent, almost to as a final backup to say, look, because people are going to be lazy, right?
Yeah.
And I think this is one of those interesting things where even if you look at something like code review,
Mm-hmm.
okay, people don't like looking at each other's like at someone else's code, for example,
yeah,
but
yeah.
it's something that the more text, the more change there is, we'll kind of like look at that and go, yeah, that kind of like looks good.
Looks good to
If
me.
there's two
Yeah.
lines, we're going to be questioning the variable
Mhm.
choices and things like that,
Exactly,
right?
exactly,
So
exactly.
if there is going to be a big set of tests or a big specification, are we actually going to go through it? And LLM as a judge could actually be there. There are going to be levels of automation that we need that backup almost. So there's
Yes.
potentially two levels
Yes.
there. One for the
And we
human.
can bring different models. We can generate
Yeah.
spec with one model
Mm.
and then ask another model if it thinks that the intent is being captured.
Yes. Yeah.
Right, and then we can iterate and make this process, and then but in the end of the day, human readable specs are much easier to review
Yeah.
than tests or code.
Yeah.
Right,
Mhm.
and this is like the main idea.
Mhm.
So now we have the entire chain. We start with the prompt, like, hey, I want to write an application that does ABC. come up with the set of specs that will satisfy those requirements. Then we have the specs. We don't trust the LLM. So the problem with LLM that it is non-deterministic, not better than random code generator.
Yeah.
Right. So my analogy,
I like that.
my analogy is, you remember this thought experiments that if you give to endless number of monkeys, endless number of typewriters, eventually they will come with the works of Shakespeare.
Yeah.
This is LLMs.
Yeah.
They're slightly better than random monkeys typing on typewriters, but eventually that's exactly that.
Yeah.
They try to get it right, and it sometimes almost works.
Yeah.
Right. So and the idea is that you cannot really trust a monkey to write Shakespeare, especially not on the first run.
Yeah.
So the idea here is that
I think that's the quote that we should take out from this entire
Absolutely.
podcast. You can't trust a monkey to write Shakespeare.
This is exactly
That's one thing. I don't care whether you're spec-centric, code-centric. That's one thing we can all agree on.
Right.
Yeah.
Never trust a monkey to write Shakespeare.
Or any kind of famous literature, I'd say.
Or code.
Yeah, or code.
Or code.
Well, I've seen some code.
No, but you've seen some code, but it wasn't Shakespeare.
No, that's true.
Exactly.
Absolutely not. Yeah.
So let's make sure that we iterate until it is.
Yeah.
And that's exactly the idea, right? So the monkeys generate spec. Will they do it right from the first time? Probably not. We want to bring other monkeys, and eventually the most important is we'll look at the spec and we say, well, it rhymes, but it's not Shakespeare.
Yeah.
Try it again with slightly different prompt.
Yeah.
Or we can just add the spec directly. Now, once we have the spec, we say, okay, we cannot trust the monkey to generate correct tests from the spec because we cannot trust the monkey.
Yeah.
Now, the problem is that we decided we're not going to review the tests. It's too much for us. It's someone else's code. We don't want to do it. The beauty of namely Cucumber, but generally parsable spec is that we don't need a monkey.
Yeah.
Because we take an algorithm and compile the specs into tests deterministically every time.
Yeah. So
we don't need a monkey.
If you run it 10 times, you'll get the same thing 10 times. Whereas if you do it with LLMs, there'll be subtle differences and maybe sometimes
of course.
bigger
And since we don't review the test, we won't even know that something is wrong.
Yeah.
Right? So monkeys out of the picture for this part. Right? So we generate the tests. Now, once we have the tests, we can let monkeys loose, type on those typewriters forever until the tests pass.
Yeah.
The only thing is we need to protect the tests because the monkeys will be inclined to adjust the test to make them pass.
Yeah.
So how do you do it? Whatever. Make the files read-only. Put them in a Docker container and make them inaccessible, like also read-only.
Yeah.
Do whatever to protect the tests, and then let the monkeys loose. Let them type as long as they want to until the tests pass.
Yeah.
And now we have the chain, right? We have a prompt that is guaranteed to capture our intent because we reviewed the specs.
Yep.
And then we have the code that is guaranteed to match the specs because we generated tests without the monkeys, and then the code actually passes the tests. So we can have the entire picture from our ideation to the end product that we can absolutely 100% trust. This is an intent integrity chain.
Intent integrity.
Because we guarantee the integrity of our intent in the code.
Thanks very much, Baruch. And next up, we're going to be chatting with Liran Tal, who I've known for many, many years. And Liran, myself, and Ashish did a security roundtable not so long ago. And in this, we swap stories about how AI tools, while sometimes they can help, they can actually sometimes make things a little bit riskier as well. How security fails and some things are missing from AI tools that provide us with data or results that sometimes are a little bit misleading, sometimes aren't deterministic, and understanding what's really beneath the covers in your data and your dependencies. So if you care about keeping your code safe, keep listening.
The LLM is just as capable of suggesting fixes first time around versus identifying issues and then creating fixes around them. What are the risks in relying upon
those fixes to, or suggested fixes to my code. And I guess we're talking about security here today, but we just had a performance session last time around. It's going to apply to a ton of different areas, but specifically, and Liran, I think you're probably well placed here from the first party code point of view. Yes, AI can suggest fixes. What are the risks?
So I would say it's against suggest fixes, but the fixes will be suggested based on some, statistical model out of whatever it got trained on and whatever context it thinks it has, but it doesn't really has the right context. And I think that is key. So like, there's so much that is going on within when you go beyond like the benchmark, sample repository that you compare, various tools around and code and like the to-do apps that you build with AI. Once you go deep down enough and things get complicated, I think at that point, there's a ton of context that is needed and understanding of code flow. So I will give you one example that I think makes total sense, where LLMs would actually try to fix something, but would actually get you hacked. So imagine that you are on a piece of code in your file, and you are working with URLs. And you practice something that's maybe like URL encoding, or like you like ask the result of the AI is giving you some code that relates to that, and you ask it to like secure it, right? And it says, okay, let's do URL encoding, or the other way around, let's do URL decoding, whatever, it depends on like the current process. let's say that this is what it suggests. And by the way, that's probably one of the things it should do. So like that's a proper process. But what happens when it is not aware that somewhere up the chain, right? Let's say this is your, service, and in some other service you interact with, or, the route, the controller, whatever, the architecture is, you actually already did a URL encoding. So now you have double URL encoding, and that is potentially like a security vulnerability, like waiting to happen due to the double encoding. And so if the LLM doesn't know to like trace your code paths and say, well, you actually did an encoding before, you should not really reapply the encoding because you could suffer the double encoding injection, then that's gonna get you busted. And so that's why it needs more than being just a statistical model. And sometimes like vulnerabilities in most of the cases, honestly, are very nuanced and very complicated. While it's sometimes easy to just, demonstrate some code injection, some cross-site scripting that we show in a vulnerability, and, there it is. It's usually most of the time, vulnerabilities are chained together. They are more complicated. People, chain one to another, like a prototype pollution to do code injection, to do command injection, to open a shell. There's like a layered approach when things happen in the real world, rather than what we kind of demo. So having that nuance and understanding is I don't think that kind of fits the statistical model. And maybe those things, maybe those LLMs and AI agents and the whole, Gen AI, general way of coding get smarter, where it will be able to then kind of like infuse several learnings and several paradigms together, like both the model, but also some applied, logic and something else. That would be great. But like at this point in time, it's just super basic. And it's as if it kind of saved you the time to like Google how to properly do, path validation versus just asking the LLM. It's not at that point where you would ask it to fix it and you could count on it.
Yeah. Very interesting. We've got a minute or so till Q&A. Let's invite the audience to also ask some questions while the audience is thinking of questions and pinging them into the chat. I'd be interested in just asking more of a cultural question. And I think when we think about DevOps changes over the last 10, 20 years or so, we've seen platform teams, we've seen this amazing DevOps engineer role been created. I personally see there's a place on that platform team for maybe certain security engineers and people who do work closely with the developers, the paved road style approach. When we so first of all, maybe it'd be interesting to hear your thought on that. But beyond that, do we see from an organizational change point of view an AI security paved road or anything like that also sitting in the platform team? I'd love to know how you think the teams are going to change. Ashish, why don't you lead us with this?
I think so there is already, I guess many companies have already started working on AI projects, and the way they're dealing with this at this point in time is the platform engineers themselves are the ones who are, because from a workload perspective, if you look at the components that get used for building an AI application, those really haven't changed. I guess you still use Kubernetes as your foundation layer. You still have databases. So all that layer hasn't really changed. So those people would still continue to work on it. I think the only point you would see evolution like that when the number of AI applications outweigh the number of regular applications you have. So it kind of happened to your point example where we started with DevOps, we had cloud, became cloud security engineers, cloud security this, cloud security that. Then Kubernetes became popular. Then let's just do Kubernetes security engineer. I think it just comes down to if we ever get to a point where the number of applications which are AI driven in your organization are more than the regular non-AI driven, or by then they are quote unquote legacy application, then yeah, maybe we'll see that, but maybe not right now, I guess, kind of where I'm coming from.
Yeah. Any thoughts, Liran?
Yeah, I agree. I think it's a bit early to call like an AI security engineer. I think it's definitely not early to have like AI engineering teams, just because that's like very like that's like AI is here, right? Like LLMs are here. They're like, among us. Sometimes they present themselves as Java LLMs, which you shouldn't trust. But they are among us, and I think AI engineering is something that should probably exist. I think AI security engineering is a bit deep down. It's indeed like, I don't know if there's like Kubernetes security engineers. It's like very, very, very specific. You kind of like, I think, like depend on the tooling, the ecosystem, the foundation, to like run a bunch of like, the security responsibility to an extent, you can like outsource the risk because it's a third party and things like that. And I somewhat feel like, Ashish, that it's kind of early to understand what it is, since we don't exactly know like even how to secure it properly. So we'll see.
Yeah. Question coming in from the audience. Min asks, it's interesting that open source code used to be seen as more secure than proprietary code because open source projects are transparent about potential vulnerabilities. I gather from what you are saying now is that no longer the case when it comes to models and agents? Did I understand this correctly?
I think it's still the case, though. I think it's still the case that both open source and proprietary data cannot be trusted. That's where I guess the whole foundation of the nervousness that we all have is that no matter which way you face, if you look at internally, there was the Ashish example that I went for, who left a bag of rotten tomatoes ages ago. That is still hanging around. There are parts of the organization that we still don't touch or talk about. That is interest. So that is never going away. It's still going to be there. If you look at open source, I think I'll go back to the episode example that you gave, Simon, earlier, where Armon kind of spoke about the levels of, like, I did my first GitHub repository back when I was trying to understand what is it to code something, and that repository is still there, to the point that today when I'm teaching people Kubernetes and cloud and all of that, I have the mature repository as well. I mean, the same Ashish has two repositories which are completely different experiences. I've never touched the first one again because I'm just too embarrassed to talk about it now that I did it publicly. But still, I think that's where I find that I would say there's untrust or nervousness on both sides. I wouldn't say one is better than the other.
Yeah.
Or more secure.
I would take I think it's more nuanced, and it's really hard to compare open source code, like comparing third-party dependencies with like third-party models. If that's what you kind of want to compare, it's super hard because I think the foundation is very different. So, for example, to review and scan, like get an audit of an open source third-party package, I could see the maintainers, I could see who contributed, I could see a Git log of all the code added, how it was added, when fixes were made, right? Like in the code, in the releases, I can see what third-party it uses to do things. I can have provenance and attestation at like the signature level of how versions were published. I don't really have that level of data at the model, right? Like I cannot see like how exactly was it trained. I am maybe being told how, but I don't know how it was actually. I don't think like the same standards of how you do code to how you train models exist yet. And I think that's like the nuance that kind of escapes, and it's kind of like easy to maybe overlook. But I think that's an important aspect when you need to audit, code versus a model.
Yeah. We're pretty much out of time, but I want to add this last question because I feel like it's a really great question from Macy here. What about social engineering risks? When teams leveraging generative AI, what steps can be taken? What steps can teams take against this? Or is it too early? Do we not know what those are just yet?
I would say there's definitely some, and I guess there are different ways to take the social engineering aspect. The one that comes to mind with Gen AI is the fact that I work as a developer and I want to know what's the salary of Ashish the CISO. Because I'm just curious. He seems to be quite fancy on the internet. I wonder where he gets all the money from. So the way people are talking about this at the moment is that there needs to be almost like a quote unquote data access manager, for lack of a better word. The way people are doing this is how do you manage access for different identities based on their roles? That is one aspect for social engineering. I would argue this could be done better in the AI world because you have a lot more sense. You have a lot more understanding of where your data is, what kind of data it is, and who can access it and what they should be doing. It's not just a policy document; it's actually implemented. I think that's where I feel that'll be really interesting. But in some aspects, really early because we haven't really seen AI-based attacks at scale. So we don't really know what social engineering could be like as well. So maybe in that aspect, maybe too early.
Cool. I'm being shoved off stage here because we have another session starting in just a few minutes. So first of all, a massive thank you to both Ashish and Liran. It's an absolute pleasure to have you on the AI Native Dev.
Likewise. Thank you.
Yeah.
Thanks for having us.
Thanks very much, Liran and Ashish. Next up, we go back to another conference, actually, this time Devox Belgium, where I interviewed Alex. And Alex is one of the authors or the main author of Backlog.md. He unpacks why this kind of like coding by gut feel can absolutely lead to chaos. And in this session, we talk a lot about how specification tricks really allow us to define what needs to be what needs to be built and really manage this in Backlog.md to be able to build using our ticketing system as well as coding agents and really get projects back under control fast. Over to you, Alex.
So yeah, we're talking a lot about spec-driven development here at Devox, and Alex, first of all, tell us a little bit about yourself, because I think some of the things that we're going to talk about with Backlog and things like that is very much kind of built in a spec-driven mindset in terms of going forward. So tell us a little bit about yourself, a little bit about Backlog.md.
Right. So I'm a lead engineer in Vienna for a gaming company. Mm-hmm. And I'm coming from an agile environment. We're using Scrum, having all the requirements with PRDs, thinking ahead a few months ahead with all of the features, like really thinking them through. And then there's the coding part. And right now, everything happens like between humans. Mm-hmm. So it's no AI, no nothing, just classic development. We have a backend team, we have a mobile development team, so they all collaborate together. This is what I'm doing during the day, but obviously in my free time I'm trying to learn as much as possible about AI and trying to keep up to date with the latest trends. And Backlog.md was basically my trial of AI and like a challenge for myself to really try to be as autonomous as possible and try to let AI code 100% of the time in my tasks. So what was the reason why I started building Backlog.md is I started with side projects, I started working with AI, I was just prompting all the time, and I was just getting really bad results. I was basically doing vibe coding. And then I realized what successful processes I use at work that makes the collaboration between humans effective enough to build successful gaming features. And then I try to learn from the human process and try to adapt it to AI. And by doing this, I realized the most important part are the specs. So everything starts with specifications, requirements, not just about the feature you want to build, but also everything around it, like security specifications, CI/CD specifications, like just the language that you should use, like C#, TypeScript, Java, whatever language. And you should have all of this context right before you start. So in order to be really successful with your tasks.
Really interesting. Let's just break that down a little
Yeah.
bit. So you were doing a lot of vibe coding. What typical tools were you using for vibe coding?
Cloud.md, Cloud.
Yeah.
So
And what were what examples of those problems did you kind of hit in Claude Code?
So the problems were like a single task problems that would repeat themselves on every single task. So what I want to mean by this is I tell the agent to build a certain feature, and he reached the goal and he managed to build this feature, but by going back and forth on a lot of things. And with the next tasks, I would repeat again the same instructions, and I would stumble upon the same issues again and again and again.
Gotcha.
This is the problem with vibe coding. Basically, every time you have a new session with your agent and you try to build as much as possible within your context window. And this doesn't scale, obviously.
Yeah, and as soon as you close that window, context is lost. You have to build that up again in your next window.
Exactly.
You create
And maybe
as well.
you forgot the instructions that you told him to prevent certain issues, and you have again the same problems.
And a lot of the things that you mentioned that you would put into specs, like security considerations and things like that, how would you describe those needs to your vibe coding tool?
Yeah, so obviously with vibe coding you can do a lot of damage. You can deploy some changes, some patches to production that actually break things. And you need guardrails, but you need these guardrails also with humans. We all use specifications about security and measures that check points. For example, like staging environment to test all of these measures to prevent issues. And with vibe coding, suddenly everyone forgot about them.
Yeah. So then you kind of mentioned you moved more into the spec environment. Tell us a little bit about that.
Yes, so I started with creating markdown tasks manually. Actually, before that, I started creating a huge markdown with all of the specifications and all of the features that I wanted to build. The problem with that, it was a huge context. And I would immediately inject this context into the model, and the agent with this model will maybe be effective, maybe not, and I will not have good success rate, and sometimes I will have to roll back, but it would be very hard to roll back a whole product or a whole feature.
And what's interesting there is you're nowhere near the context window, you're nowhere near the maximum context size.
Yeah.
You're just hitting that mark whereby the results based on the amount of context you provide degrades massively, significantly from that.
Yes, this agent have a feature called compaction. This basically tells the agent to make a summary of all of the previous conversation and start with a minimum context from that summary. But the problem is that the instructions that are contained in this summary are half of the ones that you instructed him initially, and you have to most likely start from scratch again because you don't know what he misses.
Okay. So what's next in the spec journey?
So what was next? The immediate next step was to split the big markdown file into smaller tasks. So I would have, similar to how you have in Jira or in Linear or other project management tools, single tasks that just define what has to be built. And I basically translated this into Markdown files because Markdown is a universal language that is plain text with formatting that both humans and agents can understand very well. And agents were actually more effective, and I could easily roll back single tasks at the time.
And you did this manually, or you did this with...
Yes, at the very beginning I was creating manually, and when I reached around 50 manual created tasks, I was like any probably software engineer would try to automate this. How can I automate this manual creation of tasks? So I built Backlog.md for enabling this and have an easy way to create tasks by using your terminal.
The best way to learn about it is to see it, right? Should we take a look at a quick demo of Backlog?
Sure.
Talk us through it.
So the first thing that you will do with to even run Backlog, you would have to install it. So you can use Ban, you can use npm or brew, and you should install it globally in your computer. Why globally? Because then you don't have to install it in every single project that you're using, and you can immediately use it in every folder. So this is going to take a few seconds, and
even on conference Wi-Fi, just a few seconds.
Yes, exactly. This is because Ban is very fast at installing dependencies, and afterwards you can run Backlog as this, no other instructions. This is going to give you some initial hints what you can do with Backlog. So you can see here, you can create tasks, you can list the tasks, you can see the board. I will show it very quickly. You can also run a browser, and again I will go in detail about this, and an overview that shows what the statistics about your project, how many tasks are finished and how many are remaining, and the link to the docs. And the next thing to do, normally you would want to create the tasks, but because I'm running Backlog inside the Backlog project, and I'm using Backlog to keep track of the tasks for Backlog itself, I already have hundreds of tasks. So let me show you how it looks, the board. So Backlog gives you a Kanban board that is configurable with how many statuses you want. So the default ones are to do, in progress, and done. And here you can see what is going on in this project. And all the tasks that you see here are in sync between multiple Git branches. So Backlog uses natively Git to fetch information from other branches. So if you work with other people, as long as they push the changes on a task. So for example, I take over task 200 and I assign it to myself and I put it in progress. As I make a push on my feature branch, you will see it also in your Backlog instance on the main branch, for example. So this is also nice to use it as a collaboration tool.
And can you filter based on branches and things like that here?
The logic behind it is it's a bit hidden from the developers.
Yep.
Backlog should be smart enough to find what is the task with the latest updated date.
Nice.
And that means is the newest state. Obviously, if you change a task by mistake, this will trigger that task has the latest update version. But in normal use cases, this should not happen.
Gotcha. Okay.
And what you can do from here, you can find the details of the tasks. So, for example, let's see one task that I would like to build next. This one, I press enter, and I immediately see the details of the task. So, what I would like to have in the near future is drag and drop in the terminal.
Yeah.
So like you do in Jira, you drag your task from to do to in progress. I would like to achieve the same in this Kanban board. So this is the task for that feature. It's not implemented yet, it's in to do. And what we can see here are the task ID, the title, some metadata about the task, some dependencies, because Backlog also supports dependencies that basically prevents the agent to work on tasks which are not ready to be started. So this is also important in a spec-driven development. We have a description that basically tells us why are we even doing this feature. So adding the drag and drop functionality, using shift plus arrow will allow the users to not leave this terminal interface and to change the progress very easily. So this is very nice from a user perspective. And we have some acceptance criteria, which are the core of Backlog, basically. The acceptance criteria is something that can be testable, something that can be easily verified and measurable, and basically represents the increments of like the smaller increments within this single task. And whenever an acceptance criteria is done, it will be ticked. So I will show you very soon how that looks. Let's open a task that has been completed. This one, for example, so you can see the status is done. It has been taken over by OpenAI Codex. Also another feature about Backlog is labels. So you can label your tasks and filter later by labels. And here we can see the acceptance criteria are all obviously implemented.
Yep.
We have here an implementation plan. I will talk about the implementation plan a bit later, but it's part of the spec-driven development. You always want to ask the agent how he would like to develop this task, and then you review. And then at the end, we have the implementation notes, which are sort of permanent context, what has been done in this task. So if for any reason a human or an agent would like to see what happened in this task, they would read the implementation notes and have this permanent context about it.
Yep.
So yeah, this is the primary interface. We also have a task list view, which is this one. Here we have just a long backlog of tasks. We can also check the details, and if it's longer, scroll. We can also search for tasks. So maybe let's find tasks about Tailwind. Yeah, this one, there is no task actually about Tailwind, but anyways, we can also filter by status. So to do, done in progress, priority again. So this is also like a second command panel where you manage your tasks.
Yep.
And that's basically it for the UI. We also have a web interface for people that like to have more visual GUI for interacting with tasks. We also have a plain mode for AI agents. Let me show you that one because I think it's more important. So for example, we were looking at task 200, so backlog, task 200 minus plain. This will show the same information but in plain text, and this is what agents should use.
Yeah, I see. Yeah. Okay, and so let's talk a little bit about, I want to kind of talk a little bit about the way in which, so you mentioned you built this a lot through specifications and things like that. How did you go about building those specifications? Did you use a tool? Did you handcraft the specifications yourself? How did you deliver that to them?
That's quite interesting because the first tasks I created manually. So this kind of format I came up manually by creating them myself. And after 4 or 5 tasks, I already had backlog CLI command to create tasks. So afterwards, I just recursively started using backlog to manage tasks about backlog.
And so backlog creates the specification about the task, which is essentially the thing, or not necessarily the specification of the task, but the information in that task that it can be used as a spec for an agent to implement that change, would you say?
So yes and no. So backlog itself doesn't create specifications.
Yeah.
So backlog is a tool that AI agents use, but it's not calling agents, it's not connected to AI agents by default. So you would have to start the flow this way. So I start Claude or Codex or Gemini CLI, and I tell these agents, hey, I want to build this feature, use Backlog.md CLI to keep track of the tasks and to split it into multiple subtasks. There are some agents instructions that come with backlog that tells the agent how to use backlog itself. So afterwards, the agents will know how to split a bigger task that you have in mind into smaller tasks that fit backlog. But backlog itself, it should be as minimal as possible and should not be in the way. It should be sort of a tool that both the human and the agent use on the side when
Gotcha. So it's Claude that kind of like determines the split almost, and then adds that into backlog.
Exactly.
For that.
Thanks very much, Alex. And to wrap up this episode, we finally have the wonderful Josh Long, amazing Spring advocate. And I actually met up with Josh at Devox UK, and now I'm starting to feel bad that 3 of these 4 are at conferences. But it kind of, it's nice that this is all wrapping up next week as well at the AI Native Dev Conference. So to wrap things up, Josh and I talk about the ups and downs of bringing AI into live business code, and we talk about some real production war stories, some tips about how you steer clear of the typical roadblocks. There's a ton of great information here and live coding that really helps people get AI into action and started in their Java environments. And just of course, before I before I wrap up here, I want to just let you know, remind you, next week on the 18th and 19th, we are in New York with the AI Native DevCon. Feel free to join us. We have a bunch of workshops and a bunch of sessions. And of course, if you use Simon M50 as a code, you can get 50% off your ticket price. Hope to see you there, and over to Josh.
We're at Devox UK today, and joining me is the wonderful Josh Long.
Hi, buddy.
Josh, how are you doing?
Oh, so good. I'm at Devox UK, Devox Hook, as we call it.
Devox.
Yeah.
Josh, we go back like how long? Many years? 15
Too
years?
long.
2010 maybe?
Yeah,
More?
yeah. I think so.
Yeah.
And I've been a fan since 2011.
Was 2010 a bad year?
No, I'm just kidding. No, you created you brought so much joy to my heart, but then you brought joy to the world. I remember the virtual jug.
Yes.
That was I just think about that all the time. That was such a genius idea,
Mm.
a decade ahead of its time.
Mm.
It took a pandemic for the rest of the world to realize, oh yeah, genius.
Yeah.
You know,
And that's still going now. There's almost 20,000 people on the virtual jug these days.
Wow.
Apparently.
Wow.
Apparently.
it's crazy.
So, people know Josh Long as the Spring advocate, the advocate in the Java space. But how long have you been with Spring, Pivotal, VMware, Broadcom?
I don't know. 2010
21.
Since 2010.
2010.
And still going strong.
Yeah.
But yeah, it's about as long as I've known you, actually.
Yeah.
It's been coincident.
Yeah.
Wonderful.
Yeah, awesome. And today we're going to be talking about Spring AI.
One hopes.
We'll be talking a little bit about perhaps why people will use AI when they're typically a Java developer, Spring developer. So we'll talk a little bit about the reasoning behind why people use it.
Yeah.
And then we'll go into some demo as well to actually show Spring AI in action. But I guess, first of all, what's the capabilities of Spring AI? What does it provide?
So Spring AI is your one-stop shop for AI engineering.
Mm-hmm.
And I think we in the Java and Spring communities in particular are in a uniquely amazing position right now. Just an amazing position, because where most people are going to use AI is in integration with their existing business logic and applications and services. That's all written in Spring. That's all written on the JVM and Kotlin and Java and whatever, right? That you're already there. They just want to hang AI integrations off of that code and make it work. Your business logic, the things that drive your business, and the data that feeds your business, that's all governed and controlled by and orchestrated by Spring-based microservices. Mm-hmm. And so this is a really natural place to start your AI journey, I think, is to enable access to that data and to that business logic from your AI models and via your AI models. So, sure, some people are going to use Python to train new models, but that's not most of us. Most of us, in the same way that most of us aren't building our own SQL database, in C or whatever, most of us don't need to do that either.
Yeah.
So I think we're in a uniquely great position. And when it comes to production-worthy, scalable, fast, secure, observable production, that's, the JVM there's nothing like it. Nothing like that,
Yeah. Okay, so AI, how does AI fit into all of this?
Well, we have this project,
point of view?
Right? We've got, Spring is a set of frameworks, Spring Framework, and then Spring Boot on top of that, and a bunch of verticals on top of that, serving different use cases, including microservices, batch processing, integration, data, security, whatever, right? And we have one called Spring AI, which goes GA, by the way, 1.0 GA 20th of May. So we had ambitions, I think. I don't know if I'm speaking out of school here or not. I think at one point we hoped it would go in GA. But and you're not going to believe this, the AI space has changed.
Really?
Yeah.
I don't believe it.
No, you.
If there's one constant,
right?
It's the AI space.
AI's change is too much.
Yeah.
It's too quick, too fast, too much, too whatever. We have a whole team of people working on this, and even they, and we got it's one of our most busy open source projects, right? It's the star history is like a hockey puck, just hockey stick rather. Yeah. Just through the roof meteoric rise in popularity and GitHub issues and contributions and everything. And it's So every time we think we're about to settle down and reach a GA mouse or GA release, whole new paradigm gets dropped in our laps.
I just assumed it was GA just by the amount I hear about it.
It's mature. People are using it. It's growing all the time. It's very, very popular. But obviously, we've just wanted to get to a point where we had the things that mattered, and I think we're there.
So as soon as there's a week of no change or May 20th,
whichever should happen first. Yeah, well, I think it's going to be May 20th either way. At that point, we're on the 7th of May, so got a couple weeks. Yeah, we don't even have 2 weeks of that. In fact, depending on when this gets released.
we could be around May 20th. It may be May 27th, actually.
Actually, that may be 7 days too late. Yeah.
Really? So let's just say Spring AI is out today.
Yeah, it's out.
GA.
Yeah.
Okay.
Go get the bits.
Yeah.
Fresh off the press. We might even have the first patch release. Who knows?
Yeah.
By the time you watch this. But all that to say, things are moving quickly, and that's okay. That's okay. But remember, we want to pair the innovation in the AI space with the idiomatic sort of approach to building apps that Spring is always so embodied, and we want that to build upon some of the pillars that Spring has always talked about, right? Portable service abstractions to isolate you from the differences between different models and image models, chat models, transcription models, etc. Dependency injection, aspect-oriented programming, and Spring Boot style auto configuration. You know?
Yep.
So you take those 4 pillars, and did I say 3 earlier? I was talking about 4.
Yeah.
And you get an approach that it gives you purchase in this new strange land, right?
Yeah.
It gives you the ability to hit the ground running. You already know all that stuff. You already know the component model. It's just a matter of applying those facets of your understanding of Spring to this new domain.
And you're going to demo Spring AI.
I sure am. I'm going to
talk
try
a little bit about as we go through.
We're going to build a very simple application here because we're kind of pressed on time. But I wanted to demonstrate a simple application that helps. We're going to build an assistant to help people adopt dogs, right? And I talk about dogs all the time because I think it's really cute. And I've got a dog, and I talk about this in particular. I talk about my dog, who's look. He's not the best dog, but he's mine, and
He's a good dog. He's still a good dog.
He's look at that dog. That's a cute doggo right there. So all that to say, not good, but he's ours. And his name is Peanut. Okay, and Peanut is the worst dog. Except then I met this other dog I learned about this other dog in the pandemic, whose name is Prancer. Prancer turns out even more of a spicy dog, right? And this lady was trying to find a new home for this dog, and she put out this hysterical ad saying, "Okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins." And she continues, "If you own a Chihuahua, you probably know what I'm talking about. He's literally the Chihuahua meme that describes him as being 50% hate and 50% tremble." She continues, "I kind of liked him better that way. He was quiet and just laid on the couch, didn't bother anyone. I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home." And she continues, and this goes on for a long time, and she signs off, "Oh, he's only 2 years old and will probably live to be 21 through pure spite. So take that into account if you're interested." That said, super cute, right? Like, that's a cute dog.
Is that a cute dog?
That is a cute dog. I'd pet that dog. Oh, look at him.
I've got two Labradors. I don't know if
The
that's a
big
cute
dogs
dog.
are great.
Yeah.
But my dog, just like this dog, small. They have the Napoleon complex,
Yeah. Yeah.
something about it.
Yeah, angry by default.
By default, and I don't know why, because I just want to pet this cute little guy.
Yeah.
So I think about this dog a lot too, rent free all the time, right? I mean, just how did such a dog exist? And by the way, this ad went viral, right? This ad went viral. So, for example, here's People Magazine talking about Prancer, the demonic Chihuahua. Here's USA Today talking about Prancer, the demonic Chihuahua. Here's BuzzFeed talking about the nightmare Chihuahua, the viral nightmare Chihuahua. And of course, here's the New York Times talking about Prancer, the demonic Chihuahua, right? So very, very famous dog. And I thought, well, that's nice. That's good that people learned about this dog. But that's not how most people roll, right? Most people don't find dogs by finding them on the internet, right? Like, you go to a shelter and you have a conversation with somebody, and you interview to discover the dog of your dreams, or in this case, nightmares. So what I wanted to do is to build such an assistant to help people go through that process, right? To find the right dog. So we're going to go to start.spring.io. I've already got this dog database here, and you can see there's our doggo Prancer. His ID is 45, and his name is Prancer, right? He's in a Postgres database. So we're going to build an application here. We're going to call it Assistant.
Is a Postgres database strong enough to contain Prancer?
It is a very, very tough ask. Yeah. GraalVM, we'll use the web stuff. We'll use OpenAI. Now, I'm going to use OpenAI. It's just a very good model, and a lot of people probably have access to it, but it's not the only model, not even close. Yeah. Here in data privacy sensitive Europe, you might prefer something like a Llama, which is a fine choice, or alternatively, we got things like Bedrock and Gemini and everything. I mean, just there's dozens and dozens of different models that we officially support, and the ones that we don't officially support, most of them speak the OpenAI API, and so you can talk to them via our OpenAI integration, right? So I'm going to bring in OpenAI. I've got the web support, don't I? Oh, I took that away. I'll bring in the Spring Boot actuator support. And I'm going to bring in, I need a vector store. Now you can use, look, just type vector store, and you can see you've got Milvus, you've got Neo4j, Pinecone, MariaDB, Weaviate, Oracle, Redis, Qdrant, Azure, Apache Cassandra, Chroma, Elasticsearch, MongoDB, PG Vector, TypeSense, Azure Cosmos DB, etc. I'm going to use PG Vector Store because I've got a SQL database in Postgres. This is a plugin, right? Vector plugin. So we're going to go ahead and open that up.
So what you did there was you added a bunch of dependencies into your Spring project, which then allows you to effectively build that into, I presume, a Maven POM file.
Yep.
When you build that, it will pull all the Java dependencies straight into your Spring project.
You know it. And actually, you know what I did? You know what I did wrong there? I forgot to select PG. No, I forgot to select DevTools. Okay. So I'm going to actually go down to M7 here because I don't know what they changed something in M8 and I don't remember the idiomatic way to do it already. But I'll use that. It's downloading the internet, which is not a good thing. We're actually on conference Wi-Fi.
We are.
No, we're not. Stop that. Stop it. No. the gall. I'm live streaming here. Okay. So IntelliJ is amazing, but if you start the project in IntelliJ before adding the DevTools, it won't enable the DevTools integration.
Gotcha.
So I retroactively added the DevTools there. Didn't I? I did not. Oh, that is so awkward. Okay, we'll go back over here. Copy and paste. DevTools is there now, right? There you go.
It is.
So now we'll go back again, do this whole thing again. Normally you don't have to do any of this stuff, but I've screwed it up twice now. Okay. POM.xml and M7. There we are. Fantastic. Reload. So here's our application. And we're going to build a controller that'll act as the thing that we can ask questions to, right? So system controller. And just have an endpoint here with the user context and then the inquiry endpoint, right? Inquire. So I'll say string inquire. And we're going to use, to do our work, we're going to talk to a chat model. And that chat model, by the way, is going to be connected. We're going to connect to it via OpenAI, and we have a key there. Now, friends, I've already exported an environment variable here, like so, right? So that's already done in my shell, and Spring Boot will normalize that into the property that you just saw there a second ago. These two are the same, but you need to specify that yourself when you connect, okay? We're also going to connect to a data source, not that one. Spring data source URI, JDBC, Postgres, QL, right? Localhost, my database, and then we'll create the username, my user, and then the password is secret, okay? Go back to here, and we're going to use the chat client that was just, there's a chat model, and then you can use a chat client. You can create as many of these chat clients as you want that will talk to the chat model behind the scenes. I'm going to inject the chat client builder and build a new one, and here I'm going to put my defaults, and then I'll use that model here to answer questions from the user to this endpoint, right? So call.content, etc., and then the prompt is a user prompt coming from the user, and that'll be a request parameter, right? Request param string question. So confusing, ignore this user path variable for now, okay? Let's just try this. So we're going to start that up.
Okay, so a user can hit that endpoint, that inquire endpoint, passing in a question as that variable, that param variable,
right?
That request param. That then goes to the chat client,
which talks to the model.
Talks to the model, which is OpenAI in this case. Does some stuff, provides an answer, passes it back to you here.
Right. Says, nice to see you. Nice to meet you, Josh. How can I assist you today?
Nice.
Great. So we made it wiggle, right? There's a dial tone there.
Go by the dog.
Yeah, right. Well, what's my name? I don't have access to. Okay, so it's already forgotten me.
Yep.
Right.
Yep.
Quite like the first time we met. I said hi, and you're like, and then moved on, and we didn't talk for a year.
I can't believe you're lying, John.
So anyway, it doesn't know.
Yeah.
So we need to help it. Because remember, you use ChatGPT, you use Cloud Desktop, whatever. They have memory, they have conversational memory, but that's not the case for the models, right?
Yeah.
They have APIs.
So we need to continue that context. We need to send that context back to it every time. Right?
Yeah, and the way you do that is by creating configuring an advisor, okay? So what I'm going to do is I'm going to have a per user map, and I'm going to pass this chat memory advisor. Okay. So up. There we go. And I'll go down here, and then the advisor, the map will say compute if absent user, right? And I'm just going to create a new one if it doesn't exist, and I'll store it in memory. Now, there's other implementations of this chat memory interface that you can use that will write to different abstractions, right? You can do like Neo4j and JDBC, and I think there's one Redis coming along. I don't know, but it's all sorts of JDBC, of course, all that stuff. So, okay, this is an advisor. This is like a filter, right? It's a preprocessor on the requests intended for the model. And basically, as we have a conversation with the model, this will get stored per user in that map. And then it's a transcript, in effect, of everything we said. And that'll be retransmitted to the model on every subsequent request so that the model remembers, oh, we talked about A, B, and C. When that person asks about A, B, and C, remember it, right? So here we go. So now we go back and we say, my name is Josh. Great. What's my name? Your name is Josh. Fine. How do you do? Right. So it's now got memory. But let's ask. But this is actually kind of a problem, right? Like, which is what's 2 + 2, right? Yeah. Okay. Great. But it's not supposed to be helping people with their homework. It's supposed to be a model to help people adopt a dog. Clearly, we've kind of wandered off in the deep end here.
And this is interesting because you see a ton of companies. What was the there was a couple of big ones. I think one was it
Amazon.
Chrysler or someone where they were basically getting it to like write a bunch of like malicious code and things like that from the sites, which is kind of
Amazon for a moment. I think their app they have an assistant there.
Yeah.
And you can actually like somebody prompt poisoned it.
Yeah.
And got it to like generate code for them instead of helping them with shopping.
It was Amazon then. Yeah.
Anyway, that's not what we want. So we don't want this thing getting too far off in the weeds. We have a mission. We want people to adopt dogs.
Unless you wanted to know how many 2 dogs plus another 2 dogs could be.
Right.
Yeah.
So what we want to do is to give it a system prompt. The system prompt is the overall tone and tenor. So for our system, okay, here we are, and cat desktop talk system. I happen to have a system prompt. Okay, I'll paste that there. You know what I just did that felt wrong? It's the wrong tool. It's the wrong one.
Yeah.
There, that's better.
Do you know? So when you switched from cat to dog there, I was about to make that joke and I thought, oh no, the only reason I know that joke is because you said it last time I saw it a couple of months ago.
I love it. So, okay, that's better, right? So we're going to say, you are an AI-powered assistant to help people adopt a dog from the adoption agency called Pooch Palace, with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. That's where we are in Devoxx. And information about the dog is available. Will be presented below. If there's no information, return a polite response suggesting we don't have any dogs available.
I bet if you put 2 + 2 in that prompt, it will still give you 4.
Sure, but we don't want it to.
No.
Okay, so that's a system prompt. That's going to dictate the manner in which it responds to us, right? It'll try and frame all responses in terms of that mission, that overarching mission. Like, let's see what it says actually. Yeah, it helps, but it gets us back on track. It's like
it's always trying to help, right? That's the thing with AI. It's like it has all that background information. It has a specific bit of context.
Right.
That doesn't mean it's going to forget all the other information. It still knows how to answer your question. Wonderful snippets from all our speakers, all our past speakers there, Baruch, Liran, Alex, and Josh. And I personally am looking forward to meeting them all again in New York on the 18th and 19th of November. So if you can join us, please do. It's $90 if you use the code SimonM50 during checkout, ainativedev.io/devcon to read more about the conference and also get your tickets there. Hope to see you there. If you're not in New York, of course, we're also streaming the main stage, so you can register for the virtual only, and also all sessions will be recorded, so you're absolutely fine if you can't make it there or you're far away and want to replay all those sessions. They'll be on the AI Native Dev site in not too long. Thanks all for listening. Thanks for tuning in, and see you next time.